Okay, we are stepping it up a little bit of a notch here and looking at some more adding and subtracting rational functions. This time we've got them with double fractions in them. So it's a little bit of adding and subtracting and multiplying and dividing all at the same time. What you need to think about sort of is each part separately first. So right now this is f over 1. So if I'm thinking about this quantity right here, I want to think about getting just that quantity first of all as one fraction with a common denominator. So I'm trying to subtract those two fractions and I need a common denominator. So if you look here and here, your common denominator will be e. So you will multiply both of those times e. Okay? And so then this will become EF over E minus 2 over E, which of course will become, I can make this be one fraction, EF minus 2 all over E. Okay, so that's just that piece. All right, then if I look at just this piece right now, again, this is f over 1 right now. Looking here and here, your common denominators, in order to subtract them, would be e squared. So I need to multiply e squared times the top and the bottom over here. So that means that I am going to have, I'm just going to do this so that that makes sense. Down here, I will have e squared f squared over e squared minus 1 over e squared, which of course gives you e squared f squared minus 1, because when you subtract fractions, you just subtract the top over your common denominator, which is e squared. Okay? Some of you, a lot of you probably, can skip this whole middle step and go right to the third step right here. You don't need to write those as two separate fractions first and then get them together. If you can do that, great. If not, then do it how I've done it. Okay? Now, this green line right here means to divide. Okay, so another way that I could write this, where I'm at right now, is to take the top, which is EF minus 2 over 2, and instead of dividing by that black fraction, by this one right here, instead of dividing by that, because that's what the green symbol means, I can change that so that I multiply by the reciprocal. Okay, that's what that means. So dividing by something is the same as multiplying by the reciprocal. So I will switch this so that it becomes like that. Okay? And you know what? This should not be a 2 right here. Sorry guys, this should have been an E. I just recopied that wrong. All right. And now you're going to look at canceling what you can. And so when I cancel this, I will have this E that will cancel with one of those and make this just simply be an E. And so then what I have is I have E times EF minus 2 over E squared F squared minus 1. And technically that denominator is a perfect square. I could factor it as EF plus 1, EF minus 1, but it's not going to be able to cancel anything in my numerator anyway, and so we are not going to worry about it. So this is what your answer should look like. All right, very similarly, okay? Same kind of situation. So I will look, this is over 1 right now. I want to get these as a common denominator first. My common denominator for the top part there would be x squared, so I need to multiply this times x squared, both of these, in order to get your common denominator. So on the top, I will have x cubed minus 1. And on the bottom, I will have x squared. When I do that, my common denominator in both cases is x squared. Okay? Here, x squared times x is x cubed, minus sign in between, and then the 1. That's how I got that. So hopefully it was okay that I kind of skipped that middle step. Then I'm going to divide by, and I will look at the denominator here. So right now, this is over 1. And again, if I'm comparing 1 and x cubed, my common denominator would be x cubed. So I will multiply both of those by x cubed. And right here, I will have x to the 4th, minus sign in between, and then 1. And then over my common denominator, which we now know is x cubed. Okay? And then again, instead of writing like that like a double fraction, I can take the numerator, which is in blue, and instead of dividing, I can multiply. by the reciprocal of the black. So that would be x cubed over x to the fourth minus 1. Okay? And my x squared will cancel with 2 of these and make this just simply be x. And technically, I could use sum and difference of cubes right here, and I'm going to just show you this and factor that as x minus 1 and then x squared minus x plus 1. That's how that would factor. And this down here is a perfect square, and I could factor that as x squared plus 1 and x squared minus 1. And then the x squared plus 1 I can't do anything with, but the x squared minus 1 can become x plus 1 and x minus 1. And so I could actually cancel this out and have that and that be gone. Okay? And then on the top, I have this x times this. And on the bottom, I have x squared plus 1 and x plus 1 left. Okay? The book may have it here. I'm not sure that they're going to want you to go that far. They may have it as this too. They may just have left it as x cubed minus 1 times x on the top and then x to the fourth minus 1 on the bottom. I'm not sure. But one thing you can't do, just so you know, is you can't cancel this one with that one and 3 of those with 1 of those, or 3 of those, and make this be x. You cannot do that. You need to think of something like this, for instance, as a whole entire quantity. And unless I can cancel the whole entire x plus 1 with another a quantity x plus 1, I can't cancel any part of that. So just be careful about that because you cannot do that. All right, and then this one's probably even a little bit worse, but we can do it. We got this, okay? You need to think about this again in parts, okay? So right now this is 3 over 1. I want to get this part right here as a common denominator. And so my common denominator when I multiply that would be 3 plus g. And I need to do that to the bottom, and I need to do that to the top. So I will have 3 plus g over, and then right here I'm going to distribute this 3 through. So 3 times 3 is 9 plus 3g, and then this plus right here, and this 3. And then my common denominator is 3 plus g. Okay? And then clearly I can take the 9 plus the 3 there and there. Oops, sorry, I didn't mean to do that. The 9 plus the 3 here and here, and make that be 12. So I'm just going to change this top right here to 12 plus 3g instead. Okay, so that's where I'm at. All right, now I still have a double fraction over here on the right. I'm not touching this 3 right here. I'm totally leaving that. And then what I'm going to do is I'm going to take this g right here, and instead of dividing by this fraction, I will multiply by its reciprocal. Okay? Now, when you multiply fractions, remember you do not need common denominators. So this is like over a 1 right now. And so what you are going to do is you are going to distribute this g through the top. So I have 3 plus 3g plus g squared on the top. And on the bottom, then, oops, I can't do that. Sorry, I lied. I need to just make my line go like this. I have 3 plus. Now, distribute this. G times 3 is 3g. G times g is g squared. And on the bottom, I have 12 plus 3g. Okay? I still can't combine it with this 3 over here because this is over 1 right now. And now I have that fraction that I do not have a common denominator with. Okay? So now if I compare these two denominators here and here, you can see that I need to get a common denominator and I need to multiply by 12 plus 3g, top and bottom. Okay, and now I need to distribute that 3. So 3 times 12 is 36. 3g times 3 is 9g. And then I have my 12 plus 3g over here, plus, and then my right fraction, 3g plus g squared over 12 plus 3g. And some of you maybe could have skipped this step, but I'm just going to show it to you just so that we don't get in trouble here. When you're adding fractions, you need common denominators, which I do now have, and my common denominator is 12 plus 3g. And then on the top, I have g squared plus 12g plus 36. Okay? And then, if you want to check that these can factor, you should always check that they can factor, because sometimes some things will cancel out. And so this may be the answer. I'm going to just check if it factors. For instance, on the bottom, I can factor a 3 out of there, and this would become 4 plus g. On the top, this can factor as g plus 6 and g plus 6. When you do that, nothing canceled, so it did not really do us any good to factor in that case, but check it, because sometimes things will cancel and you can simplify a little farther. So this is where it's going to end up, since when I factored, nothing mattered. If you want to, I guess if you want to leave it, I suppose, as g plus 6 times g plus 6, or g plus 6 squared would be another way to write that. This answer would be okay too, either way. All right, and the very last one right here, and this one goes a little bit faster than the last one. But again, this is over 1. I need to get a common denominator here and here, so I will multiply by b. And so on the top here, I have bc minus 5 over my common denominator, which is b. Okay? On the bottom, this is a 1. My common denominator here is b squared, so I need to multiply by b squared. So then I will have b squared c squared minus 1 over my common denominator, which is b squared. Okay, and again, you will rewrite that as the top fraction, and instead of dividing by the bottom fraction, you can multiply by the reciprocal. Okay, and of course this b will cancel out with one of those and make that be that. And then you will have b times bc minus 5 over b squared c squared minus 1. And that is about all you can do.